If we have the implant guide or surgical guide license in our Planmeca Romexis, so we basically see this icon here in the toolbar. After positioning the implant or several implants in the plan, we can continue to designing a surgical guide based on the plan made. Before moving on to guide design, let's complement our implant with the sleeve. So if we have the implant activated here in the plan and open our implant library, we can see the respective implant directly selected here. And here in this list below, we can see all the surgical kits available for this implant in our library. So from here, we could select, for example, this Straumann sleeve, for which we would see also the preview here. And if there wouldn't be the sleeve here in the list that you would like to use in the actual surgery, you could also design your implant guide without the sleeve model in the plan. So in that case, you would just specify in the implant guide design dialog the right dimensions for the sleeve holder. Let's still specify the tooth number, and then let's replace this implant with our implant and sleeve combination. So now we can see our sleeve model here in the plan, and we can also see it here in the object browser. If the sleeve has these small arrows next to it, that means that we can change the distance between the implant and the sleeve. So there would be several drilling lengths available. So we could change that. And also when we hover our mouse here on top of the sleeve in the object browser, we can see the drill length for that distance that's currently specified. So for some implant manufacturers, there aren't these arrows, so they only have one drilling length available. We can still check the sleeve here in the 3D rendered view. So let's, for example, hide the 3D data using this slider here on the 3D rendering tools. And we could now still rotate the sleeve when needed. So let's open the sleeve properties here in order to find this rotation angle slider. So if there would be the need to rotate the sleeve because it would be non-symmetrical and it wouldn't be in the optimal position in the beginning, we could use this rotation angle here. Let's then close this, and before continuing to implant guide design, let's still make sure that we have only one fitted model visible in the plan. So in this case, I had already earlier hidden the individual virtual crown for the patient. Then we can continue the surgical guide planning by clicking on this icon here in the toolbar. Here we get this small wizard for designing the guide, and then we have the intraoral scan on top of which we're going to design the guide, as well as the implant and sleeve models visible. So these colors here in the scan indicate undercuts. So wherever we see red in the scan, that means that there's an undercut on which the guide surface will not follow the tooth surface, because otherwise we couldn't insert it in the mouth because the teeth are more narrow here. If there would be the need to change the insertion direction that is suggested by the software and to calculate new undercuts based on that, we could orientate the model here in that direction in which we would like to insert the guide in the mouth, and then we could click here on Set Manually. So this would give a new insertion direction for the guide and calculate new undercuts based on that. Next, we could specify the area on which the guide would be designed. So we could just roughly define here the area, and we could rotate the model with our right mouse button, and we could include more areas. So now basically everything that we see in brighter colors would be taken into account in the guide design. We would also have the option of resetting the area at this point, or then we could activate this remove button and we could remove areas at this point but we can also then later on modify the guide and remove all excess material. Next, let's take a look at a couple of parameters that are used when creating the final guide model. So these parameters are material thickness, then gap to teeth, which means basically how tightly the guide is seated on top of the teeth, and then gap to sleeve, which means how tightly the sleeve would be seated in the sleeve holder surrounding it. So the optimal parameters might depend a little bit from the printer, as well as the material used, and also different users might have different preferences. So here in this drop-down, we have optimal values suggested for a couple of printers, but like I said, you might have different preferences. So you could always select the printer here, open these configurations, and change the values. So these changes would then be saved here, and you would be using the optimal values the next time as well. Also, it would be possible to add your own printers. So we could click on this icon that has a plus sign next to it, and we could give our own printer a name, and then we could specify the values that we would like to use and save our own printer in the list. So now we could see our own preferred parameters here pre-configured as well. Then we could also specify sleeve holder parameters when needed. So here we could open a drop-down that would show several implants if we had more implants in the plan, and we could specify here the values for the sleeve holder that is created for the sleeve. So here by default, for this case, we can only modify wall thickness. So how thick a sleeve holder is generated here, because this inner diameter, height for the sleeve holder, and the distance from implant already come from Strawman protocol in this case. But instead, if we wouldn't have a sleeve model in the plan, we would need to specify here what size of sleeve holder we would like to be created in the guide. After specifying these values, we could continue to calculating a preview of the guide. So we could firstly also activate here this option that removes the sharp and thin edges of the guide, and then we could click on this preview. So after clicking there, we can see a progress bar here on the bottom showing the progress of the preview calculation. After the calculation has finished, we can see this initial model of the guide, and like we see, we still need to do some modifications. So we could firstly activate here remove material tool. So this would give us this eraser-like tool with which we could remove any excess material out of the guide. Let's firstly resize this tool a little bit by keeping Alt down on the keyboard and by using our mouse wheel so that we can remove more material at the same time. So while the tool is active, we can rotate the guide with our right mouse button, and we can remove all excess material. Let's also check it from the other side. And this tool we could also use for generating small windows on the guide so that we can check the seating in mouth. So we could again resize the tool, and we could make these small holes. By the way, if we would make a mistake in modifying the guide at any point, we could use these undo controls here, or then redo the change or revert it back to where it was after calculating the preview. Other modifications that we can do here is that we could add bars also. Here we could specify also the diameter for the bars. So for example, if this leaf holder area gets narrow and we would like to add some support here, we could click on the starting point of the bar and on the ending point of the bar, and we get this bar added here. So we could add these bars anywhere in the guide, wherever we would like to have some extra support. Then finally, we could also add text. So we get the patient name here automatically, but we could also modify the text. And then in order to specify the right position and size for the text, we would be zooming in and out the guide model and rotating it. And then we could drag this text box window here on top of the guide and click on create. So now, okay, let's click here on show only guide so that we could see the guide model that we created, and we see also the text embossed here on top of the guide. So once when we are ready with the modifications and we would like to produce the final guide, we can click here on create guide. And also we can directly export the final guide model as STL format on our computer. So there's no cost for exporting the guide as STL. We can get it out in this open STL format so that we could use our own 3D printer or send it anywhere to be manufactured. Also, we could produce implant report at the same time so that we could, for example, use it in the actual surgery to check that everything is all right. So once when everything is ready, we can click on create guide in order to create the final guide model. We still need to agree on this disclaimer stating that we have to take responsibility for the guide created, and then the final guide model gets calculated. So here we could specify the folder and the file name for the guide saved as STL format. And after creating the final guide, we are taken back here in Romexis Implants module where we see our guide. And now we could also specify what comments we would like to add in the implant report if we decide to generate one. So this is our implant report containing patient and clinic information as well as the comments given. And then we have a view from Romexis 3D. And for every implant in the plan, we have one page specifying the information about that implant, the dimensions, tooth number, if we specified that. And then we also have information about the guided surgery kit to be used. And also we can see a view of the implant position in the plan. This implant report gets saved also inside Romexis, so you can find it here in the file module for the patient. And if we didn't export our guide model directly after creating the final guide, we can export the guide with this STL export here in the upper toolbar. So from here, we could select the implant guide and we could export that in STL format in our computer.